data can be used in flood control. So first, I would like to give an overview that what are the problems that is a part of literature review. What are the problems?
Hello.
Yeah, yes, madam.
Yes,
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 madam. Can you
continue.
hear? Yeah, please.
Yeah.
So uh, our topic is big data, use of big data for flood control. So what are the benefits we can derive from the big data in civil engineering? So this particular aspect of big data, we have first analyzed the literature review that how Surat is being affected by the flood and other countries are being affected by the flood. So what kind of data can be generated which can be used as a big data for meeting the decisions requirement at apex body. So this is what the literature has portrayed that uh, the damages has been caused by the flood. So flood control is needed. Now various researchers have given the problems of flood and its damage made to the cities, right? And we have focused what is about the Surat city. Surat is known for textile and diamond, but now due to frequent floods, Surat is exposed to frequent flood, both river flood and khadi flood. So both types of floods are khadi is passing from the city in between. So flood of khadi and flood of river both are impacting the city. So uh, Surat is now also known as flood city. Uh, we have mentioned the years in which flood has occurred in the city, and because of this we have realized that there is a need to focus on big data as urban development is there. So because of urban sprawl and all other developments in the city is under a problem of flood exposures and flood controls. So now this is where we have developed the structure how Surat Municipal Corporation and Government of Gujarat can develop such kind of things. So what will be the input for big data server? So these are the 8 areas which will provide the data to the server. Then we can use the data analytics. This is an overview of the paper. Another paper is under progress where we will develop data analytics. So based on this big data and with the help of data analytics software and data visualization, the information will pass to state government, municipal councillors, NGOs, e-governance body of Surat Municipal Corporation, city collector and other dam authorities for how much to discharge in the context of lunar calendar and digital map that is like Google, Android applications. That is new development in the Surat city. So all this will be the real-time data, and these are all the advantages which we can derive from big data for flood control. We can simulate the model that if the lunar calendar is this and discharge from the Ukai Dam is this, what will be the situation in Surat, in city area? So that will provide an idea that how much to discharge, either to control discharge or we can have a discharge so that our sea can accept that particular water. Now, it's a real-time detection that whatever has changes has been there in the upstream of the dam. Accordingly, decisions are being taken. So this big data can be used by state government, municipal corporations, e-governments, NGOs. So they can coordinate. Like e-governments can guide on social media app, WhatsApp, and others can be coordinated with the same one, and message can be propagated. Also councillors can take decisions where to move the people in the context of flood which can be arise in the city. State government can guide according to the collectors and commissioner of the city. NGO self-help group can also get the benefit from this big data, and city collector dam authorities can coordinate, and rescue team can work accordingly from the fire departments and others, so that the where boats are to be deployed in the city, so that people can be easily rescued from the flood area to non-flood area, right, based on the contour map of the city. So where the higher level, lower level, and academic institution can use this big data for simulation and other purpose, so that students can be trained and simulated outcome can be developed to guide the decision makers. citizens and other nodal bodies can also be benefited from such kind of things. The major in the area of, so the data can be is robust in nature and high that can provide output to the people. There are around 36 hours for uh, water to reach to this discharge from accordingly within and half days period. What kind of strategies to be authorities that can derived by this big data and which insurance companies can get according to this level. What kind of general insurance companies factories which are being there in Wet Road and other areas are in the nearby vicinity of Tapi River by the flood. So accordingly, in the context of this, insurance company can charge the premium. So that premium within the city can vary. If it, then insurance premium will be on a higher side. If it is non-flood zone, then insurance on a lower side for the said amount. So this can be one of the decision making opportunity for insurance companies to use the big data of past events and accordingly provide the premium to the people. So there cannot be any burden to the people who and a justified premium for the which are being exposed to the of decisions can be made by the insurance companies for their own work. And the conclusion is based on this experience, we can say that estimated risk of flood can be minimized decisions. It has been over here, this particular, the big data generated are real time data for the data analysis. So computer simulated the hack race and all these softwares, if we link up them with big data, they can show a map, inundation map that more near the less in the context of lunar calendar, because the Pal and Hazira and others will be exposed by the lunar. So the day on which there is a lunar high tide level in the sea, the water inside the city, because the water discharged from the dam or water which is going from the city is not being accepted by the sea due to the level. So in this particular situation, what to do? If it's a low tide, then water will move. So such kind of analysis or big data can give. So if such kind of models can be developed analytics with the Python and other softwares that can provide a multiple benefits to the people to simulate and use this big data for flooding. Thank you very much.
Yes, sir.
Sir, what is the technical solution you are proposing over here?
So technical solution is to collect the past data events and simulated model to be developed that we can.
Which technical in big data, which tool you are planning to use and how?
For output, we are planning to use HackRes. Okay. So based on that HackRes, we can estimate the flood level and the data which can be tested with the help of database management system. We can use Python for data analytics.
Okay, fine. Thank you.
Yes, thank you.
Thank you, Mr. Pankaj.
Thank you, sir. Thank you, madam.
Yes. Move to our next presentation. Vandita Srivastava.
Yes. Hello. Am I audible to everyone?
Yes, you are audible.
Okay, I'm going to share my screen. Hey everyone. The topic of today's presentation is Cognitive Internet of Things, Exploring New Horizons for Elderly Care by Training Intelligent Devices. I am Vandita Srivastav. I am a student in Center for Emerging Technologies in the 5-year BTEM Tech program. The objectives
Wait,
of
your screen
my
is
presentation.
not visible. Done.
Is it visible now?
Yeah, yes. Continue.
Okay. The objective of today is we'll first see the state of elderly people in India, then we'll talk about the Internet of Things, cognitive IoT, machine learning, intelligent devices, then we'll figure out the system implementation process, and then working on conclusion. First, let's see the state of elderly people in India, which is quite dire and it's extremely sad, especially because India prides itself in being a family-oriented country. India has a population of 104 million elderly people, out of which 51 million are male and 53 million are females. Out of them, 4.8 people above 60 years live alone, 9.8 people live with their spouse who are of the same age as them, and 15% people live in homes with no one below the age of 16 years of age. In total, 15 million people have been recorded to be living, and they have no way of seeking help or getting immediate medical. Something happens to them, which is quite sad because they have a lot of health problems
Hello,
and they are not
Vandita.
able to help. Yes, ma'am.
Maybe you have a slight network problem.
Um, okay, so
Okay. Okay, continue.
then, oh, hello.
Yes, now it's perfect. Sharing.
Okay, I'm so sorry. Okay, am I now audible and the screen is visible?
No, not yet. Share your screen.
Okay, okay. I'm very sorry.
Set your mic properly. Okay? Done. Continue.
Hello.
Yes. Yes, yes. Done.
Okay. Let's first see what is Internet of Things. Internet of Things or IoT refers to the billions of physical devices around the world that are now connected to the internet, all connecting and sharing data. Connecting up all these different objects and adding sensors to them adds a level of digital intelligence to these devices that enables them to communicate real time and to use the data for collection and analysis. When we integrate artificial intelligence into this, then the data collection and analysis becomes easier, and we are able to identify correlations and patterns across these different data types that we get from IoT devices. This allows them to make intelligent decisions, making it not only the Internet of Things, but the cognitive Internet of Things. So, what does cognitive Internet of Things mean exactly? It means that we are giving the system the process to stimulate human thought processes, which is understanding, reasoning, and learning. Understanding means being able to take large volumes of both structured and unstructured data and derive meaning from it. Reasoning means using that model to be able to derive answers or solve related problems without having the answers and solutions explicitly programmed into the system. And learning means being able to automatically infer new knowledge from the data. So in cognitive Internet of Things, the system utilizes the extracted data from the IoT devices in a process control loop. The devices interact with each other following a context-aware perception action cycle, with perception as the input from the physical environment and action as the output to it. Then it uses the methodology of understanding by building to learn from the physical environment. This is done by analyzing the data to form useful semantic and knowledge, and then to plan and select the most suitable action. This knowledge is then stored in databases. The stored uh, the stored knowledge is used to adapt itself to changes or uncertainties via resource efficient decision making mechanisms. And this capability of decision making is given to the system by the use of machine learning. The machine learning provides the system the ability to automatically learn and improve from experiences without being explicitly programmed. Machine learning enables analysis of massive amounts of data, and it has two main processes: training and testing. In this, the training process is greatly improved by integrating the multiple different data sources that we can get through IoT. There are three main machine learning applications: learning association, classification, and pattern recognition. Out of them, pattern recognition can be used in our use case, which is elderly care, as the elderly mostly have a fixed schedule that they follow daily, and any deviation from it can indicate a number of things about their situation and health. What IoT uses intelligent devices. Intelligent devices is any type of equipment, instrument, or machine that has its own computing capability. And as computing technologies become more advanced and less expensive, it can be built into an increasing number of devices of all kinds. They can then be connected to form a network to create our CIoT system. And the intelligent devices that can be used in the elderly care system are wearables, especially fitness bands that can be modified, and they already have the ability to monitor health related things such as heart rate, temperature, etc. And then we can also use intelligent motion sensors that can be placed at the gate of each room to monitor the times the elder person enters and exits a room. Now we move on to the system implementation process, the first part of which is the IoT platform, which requires these four main things. Sensors and actuators. Sensors is a hardware device that takes input from the environment and gives it to the system by converting it into electrical signals. Actuator is a device that converts the electrical signals into the physical events or characteristics. Then gateway creates a bridge of communication between the IoT sensors and actuators and the internet. The software for analyzing data will be given to us using machine learning, and the end application will be the service that is the final product that we create. Now we move on to the CIoT process. CIoT process uses machine learning to make the decision making algorithms. We have already discussed pattern recognition algorithms will be best for our use case, because pattern recognition is a process that looks at the available data and tries to see whether there are any regularities in it. So any anomaly detection algorithm which uses pattern recognition will be able to detect the deviation from the daily routine or pattern of the elderly person. Then we also need to store all this data and expand the dataset over time to get even more accurate results and to adapt to the change in the activities of the elderly person over the years. Now we move on to edge computing. Edge computing, as opposed to cloud computing, brings computation and data storage closer to the devices where it's being gathered, rather than relying on a central location that can be thousands of miles away. This is done so that data, especially real-time data, does not suffer latency issues, which is very important in this case as the elderly person requires immediate action in case of any issues. These edge devices can include many different things, such as an IoT sensor and gateways. The three main things that we can achieve through edge computing without having to resort to cloud computing is process management and assistance, equipment and environmental monitoring, and real-time data analytics. Now we move on to working and implementation. The elder care system will be installed directly in the home of the elderly person, and a fitness band or something similar will be given to the elderly person to wear on their wrist at all times, which will monitor their heart rate, their temperature, and any other health related statistics. Then motion sensors will be put at the gate of each of the rooms so that it can detect the amount of times an elder person enters or exits a room and at what time the elder person enters or exits the room. Then the anomaly detection algorithm will be able to detect abnormalities. For example, if a grandma enters the kitchen at a certain at a certain time to make breakfast every day, say at 7 a.m., and she makes it in half an hour and comes out of the kitchen, and this one day she has not gotten out of the room even when 45 minutes have passed, or 35, even 35 minutes have passed. This is an abnormality in her behavior. And then the detection algorithm will send a signal to the actuator to send an alert message to the responsible adult, and the responsible adult will take the appropriate action. And this responsible adult can be anyone. It can be the sons and daughters of the elderly person, or even it can be the hospital as well, if the situation depending on the severity of the situation. If it is an emergency, like the heart rate has plummeted and it is likely that the elderly person has had a stroke or has collapsed, then it will directly send the message to the hospital. Now, my concluding remarks about this are: our elders will benefit greatly from the use of CIoT. The focus will be on wearable devices and motion sensors, not on video capture. This is because even if video capture seems like the best course of action and the easiest course of action to keep a tab on the activities of the elderly person living at our homes, it invades the privacy of the person who is being video cameraed all the time, and it is not good to invade their privacy, and it is not a very dignified way to live. Then the world is moving forward fast and technology is advancing at a rapid rate. So it's only fitting that we take our elders with us in this journey into a new and better future. CIoT along with machine learning is still in its early stages of development. We need to make new algorithms and find new ways of implementing them. With advancement in machine learning and CIoT, new and better features are sure to be added in this field. Thank you. Do you have any questions?
Thank you, Vandita. Yes, sir.
No, nothing. Thank you.
Okay. Thank you so much.
Yes. Yes, our next presenter, Anish Patil.
Hello, ma'am. Am I audible?
Yes.
Yes. Uh, Let me just share my screen.
Yes.
Let me know if it's visible right now.
Yes, it's visible. Go ahead.
Good morning, panel members. I am Anish Patil. I'm a final year BTech student from National Institute of Technology, Karnataka, Surathkal. And we are here with a paper which is named Multi-Device Login Monitoring for Google Meet using path compressed double tree and user location. The idea of this particular experiment was the idea of this particular experiment came from the fact that these days in the COVID scenario, work from home is hugely ubiquitous. And Google Meet being a free platform, both in the education scenario as well as the corporate scenario, is being widely used. Today, there are over 100 million users for Google. And this technology is very personal because it uses technologies of the camera and the microphone, and hence it's very important that the security of people be maintained. Uh, since I will be mainly focusing on Google Meet, which is provided free, uh, let me mention a couple of features. So every link is valid for up to 90 days. Hence, every link can invite members and people can join them. Up to 100 users are allowed. And Google uses the term that it's secured with end-to-end encryption. So we dug a little in. We tried to understand what common security threats to such applications and platforms are, and what the TLS secure tunnel would be in a case where a video conferencing is going on, right? But it hasn't been that such platforms have always been safe. There have been several vulnerabilities. Uh, in the recent past, Zoom has been targeted with path injection attacks and relay attacks. Uh, Google, in fact, was also had a brute force susceptibility a few years ago that was actually discovered by an independent researcher. And since then, Google has worked a lot to make any such attacks non-feasible, as well as since because of the deep integration with their own web browser, that is Chrome, Google stands to be very, very secure in today's date. But even then, what if the identity of someone else can be presumed? What if someone leaks and leans over your shoulder and sees your passwords and user IDs? Can Google help you? Can Google Meet help you in understanding if someone is presuming your identity? This is something that we tried to understand and observe. So our basic motivation was that even though major video conferencing platforms used by millions of people might be secure, there could be attacks on it, especially because of the Google Meet Rowlet, which was a brute force attack. And identity theft is the particular angle that we need to focus on. So what were the three observations that we tried to tackle? The three observations were basically that Google Meet allows an unlimited number of devices for a particular account to log in. By unlimited, I basically mean that within the realm of the total number of users. So if there are 100 users allowed, you can have you and me chatting with you joining through 99 devices. But the question here is, would you be using 99 devices? No, right? Then why does Google allow it? Google Meet allows one user account to join multiple meets as well. This, although seems like a very useful feature, it actually is counterintuitive to the fact that a person at a given time can focus in only one meet. And then Google Meet also allows a meet to be carried out in the absence of the host in case the host leaves the meeting. Um, in Zoom, the host usually has a button called end meeting so that everyone is kicked out of the meet as well. But Google does not provide this in a certain context. So hence we tried to experiment with this particular concept and see how we could provide a model, a simulated backend for tackling this particular issue where people from different places, different cities could log in through the same account, maybe to the same meet or different meets. So for this particular thing, we used tri-data structures. The objectives that we came up with were to model a database so that it's random, consistent, as well as it's huge enough for our particular study, as well as to find out what the time complexity of this particular experiment is, or the algorithm is. And we also try to prevent the multiple login of an end user in a meet from different locations using a double try. So let me come to what the database is, and then I'll move on to what a double try, how we use the double try. So the database basically assumes that these are the different aspects of the particular user and meet that will be recorded, and we expect even Google might have these factors at least, and they would in fact have a lot more things. So that would be the email ID of the user. In the case of Google Meets, those are Gmail IDs. We have the meet links. The meet links are in forms of e/character. That's the IP address of the user. The location of the user can be retrieved from the public IP address. So if it's a phone, it's basically your ISP. If you have your own domain, like a big institute, then you have your own public IP located. Timestamp, when the meeting started, when the meeting was joined. The JORL joining value that you see here is basically joining or leaving. 0 denotes joining, 1 denotes leaving in our particular database. We also have a Boolean value for admin recognition, and we have the device. So moving quickly on, this is a sample of how the how the database looks when created randomly. We created around 500,000 unique records using several random functions in Python. And what the double try basically means is that at the parent level, we have a meet link try. So this particular try encompasses all kinds of meets. This is possible because Google follows this 3/4/3 structure for their Google Meet links. And the character representing the node is the structure of the node. Now, whether the node is terminal or not, we know since there are only 10 characters possible. The total number of attendees are also being present at the end of the node, the admin's email, the second try, as well as the children node. So at the end of each of these nodes is another try. And what is this try? This try is the email address of the people who are in the meet. So what this helps is basically when we try to find whether person A is in a particular meeting X, we just traverse the first try for meeting X and then try to traverse its child try for person A. So this is what we're doing. And the second try has its own characteristics. It also stores the number of logins of that person, especially because we are here trying to understand whether a particular person is trying to log in from multiple IP addresses. And we hence need to know how many times that particular person has logged in and what is IP addresses of each login where. This is the structure of both the tries. The meet try, as you can see, is there on your left, and the email address try is there on your right. Moving ahead, the flow diagram basically encompasses what our flow of data is. Once we start, we see if a recorded particular present. A record basically refers to an email ID. If not, then we just have to add the person. But if the meeting does exist, then is the person joining? And if the person is joining, is he an admin? If he is an admin, moving on to the left, then okay. Has he already used 2 or more different IP addresses to exist? If he has used 2 or more, then let him not add. And if he already has joined in with 2 devices, then let's not add him. But if he's not an admin, then we need to see if the admin of the meet himself is present or not. And if the admin is not present, then we also flag it as a suspicious actor. Going back to the right side of the data flow diagram, if the person is not joining the meet, then we just check if the IP address of the particular person exists or not. We delete the user and his IP address so that we can update the meet counter. That is basically if a person is leaving the meet, then we just need to make sure that the meet, once empty, gets deleted. And this also tackles the fact that a particular meet, once everyone leaves, gets deleted and does not exist anymore. What the complexities of this particular algorithm were was that since we are using try at both levels, adding a participant as well as removing a participant, both are of the order length of meet link plus length of email. Here, length of meet link, as I said, is 10 characters, but the length of email can definitely vary. The ending string at gmail.com remains the same, but the starting string can vary, and hence this is a variable factor. The important points to be noted here is that the try is path compressed. So if you ever find 2 meets or 2 email IDs that kind of have an overlapping substructure, then that is efficient. Removal and addition of meet as well as participant is also efficient, and any common strings that we know will be common, such as meet.google.com/ or the https/ will definitely not be considered. We had an experimental setup for this particular experiment that we wanted to put in a presentation as well as a paper so that people could carry out the experiment themselves. This is a sample log file of this same, and the results where the different scenarios are considered, where a participant is either added or removed from a meet. If a participant tries to join a meet from the same address multiple times, and you can see that this device count goes from 0 to 1. These are names of random devices that we're assuming. And access of a link before the admin has even joined will always result in failure, as well as user trying to join a meet from more than 2 different IP addresses is also flagged as inappropriate and hence is not allowed. The time taken, as you can see, is that since we are using a trie structure, the graph is linear for even up to 120,000 entries as we check. And our most important conclusion were basically that a system can be designed even by novice users for such a peripheral, a system for preventing access of a meet link before it is created by admin, and also optimization can be achieved. Our most important aspect was trying to have a base paper which has not been there in the research industry, something that targets very popular applications, and trying to see how we as students, even being novice developers, can improve, can contribute, and our paper tries to do the same. If people or juniors or anyone else does see the paper, and even we do aim to do more future work in this particular prospect regarding this exact experiment, we try to look further into active participation and trying to have a master tree for email addresses as well, and explore this if this feature can be added through Chrome extension directly to Google Meet instead of inbuilt into Google Meet. Thank you. I'm open to questions now.
No, really very good work done.
Thank you, sir.
This scenario. Congratulations. I don't have any question.
Thank you, sir.
Okay. Thank you, Anish. Yes, we move to our next presentation. Sonia. Hello. Sonia, are you here? Please unmute yourself. Hello. Yes. Hello. Are you there? Hello. There is some issue. Hello. Sonia. Might she has a problem. Now we hold her presentation. Move to our next presentation. V. Mohan. Dr. V. Mohan.
Just hear me. Hello. Good morning.
Yes.
Hello.
Yes. Good.
Just a minute. I'll share my presentation.
Okay.
1 minute. Share. No, it has stopped. Just a minute, madam. Just a minute. I'm trying to share it.
यारला ना वरना जी मैं
Ma'am, I have a difficulty in sharing my screen. Few seconds, please.
Okay. Try to find.
Can you visualize my presentation, ma'am?
Not yet.
Is this?
Not yet. Please share your screen again. You have all rights to share your screen.
Ma'am, can you just permit me to log in from other system? 2 seconds.
Okay.
Right, I'm finding it difficult. I'm
Okay.
sorry. It comes out of my screen whenever I start sharing it. Screen.
Not yet.
Is this viewable, madam?
Not yet.
Hello?
Yes, yes, not yet. Please
Oh.
share your screen.
Not it.
No.
Ma'am, I'll get into.
Downside is a green button is here. Please click directly on that button. You just share your screen.
Oh, I think I have a difficulty. Give me one more slot, madam, please. It's over.
Okay.
I'm
Now
able
we
to.
hold your presentation. Move to our previous Sonia.
Right. I'll definitely wait.
Okay. Yes, Sonia. Have you solved your problem now? Hello? Hello, Sonia. We wait for 2 minutes for both of you, Sonia and Dr. Mohan. Hello. Can you hear me, Sonia? Hello. Sonia, can you hear me? She has a difficulty, so please hold her presentation again. Yes, Dr. Mohan.
Ma'am, I'm trying to present it from my laptop.
Okay. Right.
Is that okay? I'm using my iPad for speaking to you. Hello?
Yes.
Can you hear me? Yeah, please. 1 minute. Can you just share my screen? Yeah.
Yes. Already shared your screen.
Yes, ma'am. Shall I mute my
Is
video,
your
madam?
login ID STTP?
No, it has to be changed, madam. It was for the.
Okay.
Can I? Will you allow me to change it now? 1 minute.
Your
Dr.
title is
Will.
Extraction of Clean Speech.
Yes, ma'am.
Okay,
Clean speech audio.
done.
Yes, I rename myself.
Okay,
I'm
no
able
issue.
to
No issue. Go ahead with your presentation.
go ahead. Okay. Now I'll present, madam. 1 minute. Good morning, all of you, respected judges, juries of this session, organizing committee members. Thank you so much for giving me an opportunity to present my PPT on this work, extraction of clean speech, along with emphasis on essential noise. My paper ID is 32. We have done this work with the help of deep neural network. As you all know, hearing is a complex process by which sound waves in the air are processed or converted into electrical signal, especially in our ear, then sent via nerves to our brain for sound interpretation. The reduced ability to hear sounds is known as hearing impairment, as you all know. It is one of the most common sensory deficits affecting human beings, especially elderly people. Hearing aid is an electronic device that is used to make sound audible to the hearing impaired by amplifying, especially conducting it to the ear. However, patients who suffer from sensory neural hearing loss, which results from deficiency in the inner ear, have also less ability to separate desired from undesired sounds, which leads to a difficulty in hearing, even with the hearing aid, especially in a noisy environment. Okay, so speech denoising or design of hearing aids are the popular research area, as you all know. However, in some situations, noise could be made more important than speech, like talking while when you are talking in a conversation, a fire alarm is activated that must be heard essentially. Hearing impaired people are the ones that could be most hurt in those situations. So because of their lower ability to hear, especially in noisy environment, the available hearing aids, which are having the demerits of a smart feature that distinguishes from desired, especially from undesired noise types. So their users have to rely on separate alerting system, especially to ensure the safety. So the denoising systems which are available currently on literature will all focus on eliminating the noise, especially the environmental background noise, as well as concentrating on only speech enhancement, especially the statistical dependence of the characteristics of the noise signals, especially it is required so that the noise removal process is very well carried out, but it is unable to distinguish the necessary noise from unnecessary noise. So it is essential that we have to add some kind of smartness to the hearing aids using the current deep learning neural networks algorithms. That is the objective of my work. So let us move on to the next slide. So you can find out we need to have the deep learning structures, especially deep learning neural networks such as deep belief networks, restricted Boltzmann machines, which are currently existing in the literature for speech enhancement. We are going to use that baseline structure in our work. We are going to have this typical pre-training process, especially in the unsupervised mode of learning in progressive learning method. At the same time, we are going to look for the fine-tuning process so that it can eliminate the effects of noise, background noise, the desired as well as undesired noise, which will purely concentrate only on speech denoising operations alone. These are all the works already existing. So let me move on to the next one, which is the deep learning, particularly which uses convolution neural network architecture, which looks for the higher order features, which will extract higher order features from the input data using convolution processes. And the convolution neural network will accept three-dimensional inputs where the spectrograms or scalograms or mill warped scalegram or spectrograms or single frequency filtered spectrograms will be applied as inputs. So the feature extraction will be carried out by the convolution layer. After the convolution layer, the dimensionality reduction process will be carried out using the pooling layers available in the CNN. So CNN can also be used for the denoising operations, speech enhancement using denoising operations. So that was the second work. And the third one is, in the literature, we could find that there are some combinations of architectures, convolution neural network in combination with recurrent neural network, whereas the feature extraction is mainly focused or carried out with the help of CNN, whereas learning and estimation is carried out with the help of recurrent neural networks. The features are extracted and trained, the noise is estimated, so that the speech denoising performance is improved with the help of a combination of CNN with RNN. But there is a demerit, as I mentioned already. The denoising technique will focus only on elimination of all the background signals and at the same time enhancement of speech signals alone. Whereas when you go for the real-time scenario, yes, there are some existing alert systems which will help the hearing impairment people, especially to indicate the emergency, like creating a flashlight glowing out or the vibration of objects, something like it gives an indication of emergency. It is very difficult to have a separate system for emergency alert alone, because more than one system the person has to carry, and it is not a cost-effective solution, and it will provide only mere indication alone. No information about the type of emergency is added. So people, those who are suffering from hearing loss, may have to have hearing aids as well as additional alert system, which will focus on the indication of emergencies. So we plan to integrate both the speech enhancement process, taking into consideration the type of noise, especially in the speech, desired or undesired speech. The system should decide whether the noise is audible or it is made to be audible or not. So restoring the clean speech from noisy signal is considered as a highly challenging task, as I have already mentioned about. Deep learning, neural network based speech learning approaches, especially when the noises of background noise or environmental noise. Recently, deep learning has effectively solved many such problems to tackle with previously used signal processing techniques. Classical signal processing based denoising methods were based on statistical assumptions of the noise present in the speech. That is the main demerit of the classical signal processing. Whereas in deep learning, no such assumption is required to be made. The power of deep learning algorithm is that it can learn a function which can map an input to a target output, especially even if the input is complex, the mapping function can be made to achieve the desired task, even when it is highly non-linear. It was made possible. So deep learning approaches. Here I'm trying to present my overall system view where the noisy speech will be given. There will be two paths. In one path, the speech enhancement algorithm using deep learning will be performed so that the clean speech is extracted through first channel. In addition to it, in parallel, we will focus on the other chain of the other branch of the system, which will concentrate on the estimation of noise, whether the noise is to be retained or it is to be attenuated. So in a controlled manner, the noise extracted from the noisy speech will be fused with the speech, clean speech, so that the person available on the other side will be able to hear the conversation or the desired signal at the same time, desired or essential noise also on the other side of it. You can find out it is given in depth in this diagram. The noisy speech is applied through the deep learning based speech enhancements algorithm, which extracts the clean speech and it is readily available. Whereas because of the clean speech, it was possible for me to use the even standard spectral subtraction techniques to remove the effects of noise from, speech from, noise from the speech, noisy speech. Noise is extracted, whereas the noise, when it is isolated, using a convolutional neural network classifier, I can very well identify the nature of the noise and a probability estimate could be made, based on which we will decide whether the noise is to be retained or it is to be attenuated, or to what extent it can be fused with the original speech signal. So that is the method through which we are trying to implement it. So the noise speech is the input to the system, where the clean speech is extracted using DNN algorithm, whereas the same spectral estimation through CNN classifier gives me the importance of the noise present in it. If it is a siren sound, or if it is a fire alarm, or if it is a baby crying sound or something like that, the essential parts of noise will all be retained and diffused with the original signals, so that you can hear the enhanced extraction of original speech along with the essential noise will be emphasized. This is the system overview. I have presented it. So the speech signals are highly non-stationary process with multiple components. You can find out that multiple components that may vary in terms of time as well as frequency. Speech enhancement process will be used to improve the intelligibility and quality of the speech signal. That is what carried out using speech denoising processes. It is a growing challenge. Still, it is to be sorted out. Nowadays, people use deep learning neural networks for denoising applications, so that extracts clean speech that I can prove with the help of the experiments carried out. So that I can find out the next one. The denoising, the total noise was removed from this noisy speech signal, whereas the hearing impaired signals will fail to hear the alert sounds such as fire alarm or the siren, which will also be suppressed. The classification of noise will be, the extracted noise will be treated separately in our system, so that we will classify based on the noise, whether it is essential or not. The separate neural network or the branches used in our system. So that I can go to the next one. I can show you when we work with the discrete Fourier transform or the spectrogram. In the spectrogram, I can extract the higher level features and the
Hello.
machines. Yes.
No, no. Okay then.
Okay. The supervised learning was attached at the last layer, fully connected layer, will help me to classify as well as to enhance the speech, denoise the signal. And now you can find out the noisy speech signals are enhanced with the help of deep learning approaches. Then I can find out the clean speech coefficients will be generated through the branch, one of the branches available in our system. And you can find out that the neural network which is available here will be using the RBN which deals with classification of noise, requires to be trained separately using the noise databases, for which we have got some speech utterance, noise speech utterances, environmental noises taken out from databases. And they are also trained with the help of CNN classifier, which gives me the estimate about the probability whether it is to be treated as desired or undesired noises, based on which the weights are allocated. So the fusion process is to be ultimately the fundamental work to be carried out, so that clean speech coefficients are also appended with the desired noise coefficient, so that I can, in a control smart hearing aid development. Yes, hello. And then EC50 data set, we can find out that there are some environmental recordings which comprises of some environmental sounds such as animal sounds, natural soundscapes, or sounds, human signals, whereas extracted carefully a portion of it from that EC50 dataset, which is also already available on internet, ECS10 database, which is an extract of the EC50 database. The essential noise signals are generated from this, and you can find out that when they are applied through the DNN process, we need to deal with the STFT, the classical STFT, where the magnitude as well as the phase angle informations are separately extracted, where the deep learning neural network is trained only with the magnitude spectrogram. The magnitude spectrogram will be useful to help, to extract denoise only the clean speech. Using the inverse STFT process, we are able to extract the clean speech. Denoising is parallelly carried out using the system which is shown here, whereas the algorithm is to deal with the speech signals. There is no doubt, but at the same time, the speech is framed, and the framed speeches are passed through windows, and as it is described by classical techniques. And the speech will be processed using STFT. STFT, short time Fourier transform spectrograms, are essential inputs for the DNN as well as CNN in our case. And you can understand that the noise aware training which is applied in the DNN will be useful in enhancing the speech, as well as it is capable of eliminating the background noise as well as the environment noise, which will provide the clean speech coefficients. At the same time, the results are shown here. And a sample result is shown here from the noisy audio, how the clean speech audio is extracted using DNN. DNN is very much useful in our case for elimination of noise. And the DNN takes inputs only in 2 dimensions or 3 dimensions, and for which we need to work with the STFT as well as inverse CTFT, STFT alone. The enhanced spectrogram will be available on one branch, whereas we will concentrate on the speech classification using CNN, classification of speech signals. I mean, noise signals. You can go to the next one. You can find out the noisy speech signal is available. And here also we are training CNN to take a decision whether it is an essential noise or not. The classification of noise classifiers are also shown here on the screen. And the architecture used for CNN is given in a nutshell like this. And we are trying to give some the technical details of it. The convolutional rectified linear layer will have 80 filters of rectangular shape. Each one will be a 57/6 and 1/1 stride, and allows slight frequency invariance as well as max pooling layer with
Hello,
filters.
sorry to interrupt
Yeah.
you, but we have time limitation, so go with conclusion.
Okay, I'll show you that. So clean speech along with the desired noise has been estimated parallelly using 2 different branches of the proposed system, and it is applicable for the design of smart hearing aids, and which will be capable of providing the clean speech as well as the noise aware speech enhancement system. That will be very much useful for the elderly people, especially for hearing aid design, smart hearing aid design. Yes, here are the references I've given you. Thank you. If there are any queries, I'm open to queries. Hello.
Yes, thank you, Dr. No, sir. Thank you. Yes. Now we all done with our all presentations. I sincerely thank our all researchers for their excellent presentations in this session and all our participants for being a part of this international conference. I hope the session was informative and knowledgeable as well. All the presenters will be getting the digital certificates, payment receipts, thank you letters, mail within 2 working days. Further, all the papers have already forwarded to Springer for publication process, and publication will be live within 4 to 5 months. So kindly cooperate with the ICTCS 2020 team for this tenure. And again, I also thank our session chair, Dr. Nilesh Modi. Thank you, sir, for your valuable presence, sir, for chairing this session. Here is small token for your presence for chairing the session. Small token for you, sir. Your e-certificate. Thank you for your valuable presence. Dear all, kindly open all camera for quick snapshot, please, for memories for ICTCS.
I need to
2020.
open
Yeah.
the camera.
Smile, everyone, please. Done. Thank you so much, everyone. Stay safe, stay healthy. Now we will end this session.